This is section 4.5, and it is about what we call L'Hopital's rule. And the rule was named after Guillaume de L'Hopital, and there's my bad French. But he wrote the first differential calculus text, and in that text, this rule came about. Here's the formal rule that just simply says that under certain conditions, the limit of a quotient, f of x over g of x, could be determined by the limit of the quotient of the derivatives. And so we'll use this if you end up trying to take the regular derivative and you would get, taking the regular limit and you would get an indeterminate form, meaning you would be dividing by 0 or something. So that's when we're going to use it. Let's look at how this would look. So in this example, the limit as x approaches 0 of 3x minus sine x over x. Well, if we tried to direct substitute, we would have 0 on the bottom, so we can't do that. So then we're going to take the derivative of the top and the bottom and still try to take the limit. So the derivative of 3 to the x, 3x is 3 minus cosine x over 1. Well, now we can let this go to 0 because we only have an x up here. Cosine of 0 is 1, so we have 3 minus 1 over 1, which is 2. So now we've got the answer. This is one that shows where you sometimes have to use the rule over and over. So if we had this one, limit of x approaches 0 of x minus sine x over x cubed. Can't substitute, so we take the derivative. And you can pretty much tell you've got to get x out of there. So you keep taking the derivative until letting x approach 0 is not going to be a problem. And so here we have 6 on the bottom after we took the derivative that many times. Cosine of 0 is 1, so your limit as x approaches 0 would be 1/6. Okay? So that's some examples. Let's look at some of the problems you might encounter in homework. There's not very many, so we're just going to look at these. All right, it says use the rule to find the limit. And you can tell if you plugged in 5 here, you would have 125 minus 125. So that's not going to work. So here's one way to do it. Let's think of the derivative. If f of x is 3x minus 15, f prime of x is equal to 3. And if g of x is equal to 5x squared minus 125, then g prime of x is equal to 10x. Okay, so now the limit as x approaches 5 of 3 over 10x is equal to 3 over 50. All right. All right, same thing here. As we approach infinity, if you're approaching infinity, remember we actually could do this with dividing each term by the highest power of x. Let's see if we remember to do that. So we would have 3x cubed over x cubed minus 6x over x cubed over 7x cubed over x cubed plus 7 over x cubed. And we should remember that these guys, you end up with 6 over x squared. These are going to go to 0. Okay? So those are going to go to 0. This cancels and that cancels. And so what are we left with? Equals 3 over 7. So that might be the way you would have done that. But let's use the rule to do this. All right. If f of x is 3x cubed minus 6x, then f prime of x is equal to 9x squared minus 6. G of x is 7x cubed minus 7. Then g prime of x is 21x squared. And then let's continue. All right, let's take the derivative of that. Let's see if I have room. Where am I going? can get back up here. So f double prime would be 18x, and g double prime would be 42x, and those cancel out if you take the limit as x approaches infinity of 18x over 42x. Well, the x's are gone, and so what do we have? 18 over 42. What does that reduce to? 6 goes into 18.3, and 6 goes into that 7. So in this way, I'm really used to doing this, and I probably wouldn't use the rule, but it is there, and you could if you're approaching infinity. All right, let's try number 3. If we let x be 0, cosine of 0 is 1, 1 minus 1 is 0, so we cannot take the limit as it is. So let's do this. F of x is 3x squared. G of x is cosine x minus 1. Okay, and so f prime of x is 6x. G prime of x is negative sine x. Okay, so if you take the limit as x approaches 0 of 6x over negative sine x, what do we get? Sine of 0 is 0. So this doesn't work. We get 0 over 0, so we have to repeat. Okay, a little bit more room. So now we'll take the derivative of the top. So f double prime of x is 6, and g double prime of x is negative cosine x. So we have the limit as x approaches 0 of 6 over negative cosine x, and cosine of 0 is 1. So we're going to have this negative out here, so we've got negative 6 over 1, which is negative 6. Okay? All right. Number 4. As theta approaches pi over 2, okay? Okay. So if we are going to let theta go to pi over 2, we would have 3 plus 3 cosine 2 times pi over 2, which would be cosine of pi. Cosine of pi is negative 1, so you would have 3 plus a negative 3, which would be 0 on the bottom. So we can't do that. We will have to use the rule. Okay? So f prime of theta would be negative cosine theta. G prime of theta would be negative, let's see, sorry, that would be 3 sine 2 theta times the derivative of that is 2, and actually that's a negative sign. Okay, we'll kind of do that. So it's 3 negative sine 2 theta, because you do the derivative of cosine, that argument, and then times the derivative of the argument. So what do we have? We have negative 6 sine 2 theta. All right, so let's try that and see what we got. The limit as theta approaches pi over 2 of negative cosine theta over negative 6 sine 2 theta. As theta approaches pi over 2, that ends up being pi. The sine of pi is 0. So that's not going to work. So we get 0 over 0. Okay? Let's try it again. So we'll go further. F double prime and G double prime. negative cosine. Well, the derivative of cosine is sine, is negative sine, and then you have another negative, so that becomes sine theta. And down here, we've got negative 6 sine 2 theta. So we would have, cosine 2 theta, negative 6 of that times 2. So let's try it with the rule. Limit as theta approaches pi over 2 of sine theta over negative 12 cosine 2 theta. Alright, so that again goes to pi. Cosine of pi is negative 1. Negative 1 times negative 12. We've got 12 on the bottom. And sine of pi over 2 is 1. So there's our limit. Okay, so we had to do it a couple of times. Alright, number 5. Okay. If you try to let x be 0, secant of 0, remember secant is 1 over cosine. Cosine of 0 sorry, hold on. Okay, sorry for the interruption. Okay, so let's think about this as if we were taking the secant of 0. That's 1 over cosine. Well, cosine of 0 is 1, so we're okay there. But we've got 2 ln 1. And if you did that on the calculator, ln of 1 is 0, so we would go to 0 on the bottom. So we can't just take it by direct substitution. Let's go ahead and do f prime of x, and that would be 18x, and g prime of x would be 2, and then when you take ln of a trig function, it is like g prime over g of x. So on the bottom, we've got secant x, which is the argument. On the top, we're going to take the derivative of secant, which is secant tan. Okay, so we've got that. And that goes away and that goes away. We could see that and that. And so when we're evaluating, we've got the limit as x approaches 0 of 9x squared, sorry, right in the original, 18x over 2 tan x. The tan of 0 is sine over cosine, which is 0. So that's not going to work. We end up with 0 over 0. So repeat. We'll do it again. And so derivative of that is 18. The derivative of this is 2 secant squared x. The limit as x approaches 0. All right. Secant of 0 we said was 1. So we've got 18 over 2 times 1 squared, which is 18 over 2, which is 9. So you only have 5 problems on that, and I think it's pretty clear. You're just taking the derivatives however many times you need to get where you can take the limit. So hopefully that will get you going.